What I want you to know about parallelograms and rectangles when it comes to their diagonals is the diagonals create what we called in geometry A alternate interior angles. So these two angles are considered alternate interior and are equal. And on this picture, that would be angle 3 and angle 2. They're equal. Now 3 and 4 are not equal. Okay? On a parallelogram and rectangle, you go to the other side and cross the diagonal. And therefore, this set is also equal. So that would be angle 1 and angle 4. That's something to remember when you have diagonals in a parallelogram. So let's take a look at all this mess here. And we can use this information. Let me show you how to use the information to find everything you need. Let's start with opposite sides. AB is 10, DC is 10. Opposite sides are equal, so that would make BC and AD equal. This would be 22 as well. Diagonals are not equal, but you do need to know that they cut each other in half. That's why this piece is a 13. This piece is 12, therefore this piece is 12. In a parallelogram, they are not equal, but they do cut each other in half. So let's look at the angles. Look at this 23 down here, go alternate interior along the same diagonal, but you cross over, and that 23 is going to be up here now. Alternate interior angles. And that's the same with the 47. This 47 would come up here and is equal. Now let's look at this diagonal. I got one angle down here. Now I can cross over and come up to the top, and I have a 72 there. Now, if I want to find other angle measurements, remember that all these are triangles, and they still add up to 180. And if I needed to keep going, I could use the interior sum of 180 and subtract the 47 and 72 on my calculator that I'm doing right now. And now I have a 61, so that triangle is complete. Remember vertical angles? I'll get into this 61 as well. So that triangle is complete and that triangle is complete. How could I complete the others? Remember a linear pair, half circle, with the 61 here? Remember, there's linear pairs and vertical angles here in the middle. So I can do 180 minus 61, and I now have 119. And that's the same with this vertical angle as well. And to finish the whole thing off, I have this triangle. And I know I'm going fast, but remember, you're going to be able to watch this on YouTube and pause it and rewind it. That this is the third triangle down here of this triangle. So 180 minus the 119 and 23. And that angle here is 38. And that means this angle up here would be 38 because of the alternate interior angles. So there's how to use that diagonal as a transversal like we did in geometry A with the parallel lines and transversals with the corresponding angles and alternate interior and all that. That's what that diagonal does. All right. Couple little questions. I like to break my questions into mild, medium, and spicy, like I like my chicken wings. So this would be a mild. This is pretty fairly simple math here. So I have A is 12 because they're opposite. And 7 and B are equal. Now, inside, opposite corners are equal. But if they're next to each other, meaning adjacent, they add up to 180. That's why this one would be 68, because 112 and 68 makes 180. So hopefully you have those concepts down. That was in the notes in the video. So another medium one, same type of concept, but then they add diagonals. So the diagonals, remember, are not equal, but they do get cut in half in the center. So that would make 10A, because that is the other half of the diagonal. B is also 10, because their opposite sides are equal. Okay, 62 and X are alternate interior. We just covered that. And Y and 33 is vertical. We covered that as well. So that's another mild one, not too hard, as long as you know those concepts. All right, here is a medium one. There's the same type of concepts, but there's a little algebra involved. So let's look at A. Well, A is easy. There's no algebra there. It's just 20. B, 2B and 28 are equal, so that means 2B equals 28. So what times 2 is 28? B would have to be 14. Then I'd look at X. I don't know what X is to work with yet, so I'm going to pause there with the X. But I do see Y. These are alternate interiors, and I would take 42 divided by 3. So 42 divided by 3 on my calculator is 14. So the X is pretty tough. So here's how I can show you how to do it. The X is the hardest part of this. Remember that you can use the triangles. So if I was to find X on this one, I could say 4X plus 70 plus 42 would equal the interior sum of this triangle, and I can make it equal 180. And I could solve for X that way. But because I don't want this video to go too long, I'm not going to do that. But hopefully you see the triangle and know that the three angles in a triangle add up to 180. All right, the last topic of the parallelogram is I want to talk about what if you had expressions on these pieces of the diagonals. Here's what I mean by that. Take a look at this problem here. It says CX and then it says XK. If CX is here and XK is here, you got to see that that's an equal relationship. Those are equal because in the center, that gets cut in half. So that means you'd set these two pieces equal to each other and solve. So hopefully that's not too bad. But the harder, more challenging one is something like this. This says CX is 3x plus 5. So let's recognize CX. Okay, that's half of that diagonal. Then it says CK. But CK is all of that diagonal. What you need to know is that these two pieces cannot be equal. What you would have to do is understand that two halves make a whole. So you could mathematically double the half by multiplying it by 2 and then making it equal to the whole. So be careful when you get, and there's questions like this on the test and on today's worksheet, that remember the halves are equal, but a half does not equal a whole. You'll have to double it, just like I just did there. Now on to the easier picture is the rectangle. Remember, every corner of the rectangle is 90, so angle 3 would be 90. And remember, we still have alternate interior angles, so that would be 60. And angle 2, if I remember each corner is 90, angle 2 has to be 30 because that's 60 plus 30 is 90. All right, now I want you to know this. The diagonals in a rectangle are equal and cut each other in half. That's the difference between the rectangle and parallelogram. That's one difference. The diagonals are now equal and also cut each other in half. That means that all of these pieces are congruent. All these half pieces are congruent. And all four of these triangles, the west triangle and the east triangle, are isosceles triangles, and the north triangle and south triangle are also isosceles triangles. Also, the west and east triangles are equal to each other, and the north-south triangles are equal to each other. So let me show you how to fill this in. This triangle, or this picture, only gives me one angle. And if I know if this bottom triangle is isosceles, I'll know that's 50. I'll also know that in a rectangle, all the corners are 90. So that's what gives me this as 40. And that means this one over here is 40. The south and the north triangles are congruent. That means I'll have another 50 and 50 on the top. Now, how can I get inside the middle here? Is remember, these are triangles. Inside this triangle, I have 50 and 50, which is 100. This has to be 80 to make it 180. And if I do a linear pair here, that means this is 100 with this half circle in here. Okay, so now this is vertical, so that's 80. This is vertical, that's 100. I already talked about this triangle being isosceles. All these are isosceles. Therefore, this one has to be 40. And 40 plus 50 is 90. Therefore, this one has to be 40. And I have now found every single angle in this picture. It is a puzzle. Remember that the west and east are equal and the north and south are equal. Last page here. So if I told you that this side was 3 and this side was 4, and the objective is to find one of the diagonals, is you have to see this as a right triangle. You have to be able to break the picture down into a right triangle. And remember, this is something I showed you in the video, that you will need Pythagorean theorem to solve this. This would be a squared plus b squared equals c squared. The c is always directly across from the right angle. So I'd say a squared is 9 plus b squared is 16 equals my c squared, and add those two together. And then the last step of Pythagorean theorem would be to square roots, and my diagonal would be 5. All right.